Hello everyone, good morning, good afternoon and good evening. My name is Vishvadeep and I welcome you all on PW Gatewala channel. As you all know that this is one of the best possible way we could help you in this type of questions where the most of the students are getting stuck, and that is MSQ type of question. Computer science is very well equipped and very well loved by GATE authorities who are setting the paper just because this is the only branch where at least 10 questions of MSQ type coming in the GATE examination. Other branches are not having that much of love or being that much of loved from the GATE organization committee. So it's okay if we are getting loved, then definitely we should respect it and we should also love the questions of the GATE paper. How? By solving them correctly. Simple, right? And for that particular thing, I am here with another session of 20 questions of MSQ type of questions. How many of you are having issue in solving MSQ type of question? Can you please let me know? Can you please confirm how many of you are having trouble and issues in solving the MSQ type of questions? Let me know. I'm just checking out the comments over here. How many of you are having trouble? How many? None? Nobody? Okay, I don't think so. It should be like that way, but still, I will take your comments. How many of you are having problem, trouble, pareshani in solving MSQ type questions? Two issues. One is speed. You are not able to achieve the speed of solving the MSQs just because to solve the MSQ you need extra time. Yes or no? Agree? Write down the word agree. Yes. Point number one, agree. Point number two, to solve the MSQ questions, you need to have more and more deeper knowledge. Here, elimination doesn't work like MCQs. If you eliminate three options, then one definitely will be correct. But here, that elimination doesn't work. So, the problem is, if you have understanding of the concept till the very, very core, till the very, very deep, then only you will be able to solve the MSQs correctly. Otherwise, what you will say? Sir, I left one question which was one option which was correct, or I tick marked wrong answer. Happens every time. It happens that one of the correct options you either just don't mark, leave it, okay, or you sometimes correct or tick mark the one of the wrong answers or one of the wrong options. Happens, yes, most of the time. That is why I am here for you guys to solve the questions, and I will not solve, you guys will solve. Now, the very first question I have handpicked today only, and not handpicked, actually created today only, and the question is very simple, but it is very lengthy. You will say, sir, this much big question, only 2 marks. Yes, this will happen in GATE examination. MSQ type of 3-4 questions will come. Those will take at least 8 to 10 minutes of your time. Then how you will solve those questions? You can solve them, but yet what happens? You will need time. And if you can solve the remaining questions in lesser time, such kind of questions you can attempt at the end. Otherwise, leave. And because of that, you are losing marks in your test. Agree? Yes, na? You are not getting marks just because you are not able to solve the questions quickly. So practice is the only solution, my dear friend. This is the question. Question is page reference sequence, which is passed through a paged virtual memory environment. 4 sequences are given. The system has 3 frames initially. Later on, frames are increased to 4. So initially 3 frames, later on 4 frames. Which of the following page reference sequence will suffer from Belady's anomaly for FIFO page replacement policy? So 4 options, one of them, maybe 2 of them, maybe 3 of them, maybe all of them may suffer from Belady's anomaly. First of all, if you forgot about it, you need to know what is Belady's anomaly. That happens in FIFO. Yesterday we have discussed though in the class, in the Maha revision. One thing which missed in the particular question, that is all frames initially empty. So this particular question is something like For each option, you will have to pass each option 2 times. 8 questions are there in the same question. That is why MSQ questions are difficult. 8 times you will have to solve. 8 times. That is why the MSQ questions are getting difficult. Solve it now. Solve it now. I'll give you some time. 4, 5. I'm not talking much so that you can concentrate. These type can come in gate. नहीं भैया, हम तो ऐसे ही टाइम पास करा रहे हैं. I'm just passing time here of the serious aspirants who are trying to, have good rank or good marks in gate examination. अब पैनिक हो रहा है बहुत. शुरुआत में अगर पढ़ाई नहीं की है तो पैनिक तो होगा, और अगर करी है तो थोड़ा सा डर लगता है कि यार मेहनत जितनी की है उससे रिजल्ट आएगा ही नहीं आएगा, पता नहीं. सी, we do have some answers: A C D A C D A C A B A C D A C A B. Different answers till now. Still, I will give you 1 minute or maybe more than that. You need to actually solve 8 number of questions here. 4 options. Each option you need to pass for 3 frames and then 4 frames. लास्ट में PYQ एज वेल एज रिविजन काफ़ी है, प्रैक्टिस भी करनी पड़ेगी. प्रैक्टिस एंड टेस्ट, प्रैक्टिस एंड टेस्ट, टेस्ट बहुत ज़रूरी है. ओनली ए. चलो फर्स्ट ऑफ ऑल ऑप्शन ए चेक करते हैं फॉर 3 फ्रेम्स. So 1, okay, there is no any 1, 2, 3, 4 page fault are there. They 1 page fault is there, yes. So 1 will replace 2, then 2 will replace 3, then 5 will replace 4. Then after that 1 and 2 no page fault, 3 and 4 definitely page fault, just because 3 and 4 both are not there. So how many page fault? 1, 2, 3, 4, 5, 6, 7 and 8 page faults are there. 3 frames, 8 page fault. Option A, same thing I'll check for 4 frames. Belady anomaly says that if you increase the number of frames, the page fault count also increases. 2, 3, 4, 1. 2, 3, 4 and 1. Definitely 4 page faults will be there for 4 references. Then again 2, no page fault. Then 5, page fault, yes. When there is a page fault for 5, the first page which comes, which is 2, will be replaced. If 2 will be replaced, then what happens? 5, 3, 4 and 1. Then 1, no page fault for sure. 2, page fault is there. Replace 3. Then 3, okay, replace 3 means 2 comes over here. 3, page fault is there. It will replace 4. And 4, page fault is there. So how many? 4, 4, 4 and 4, 8. Same number of page faults here also. Page faults, 3 frames, 4 frames. Same option, same answer for option A. No any Belady's anomaly for option A. Option A, no Belady's anomaly. For option A, Belady's anomaly is not there just because Belady's anomaly says page fault count increases. Here it is not increasing. Option B. Let's take option B. Option B. 3 frames. 1, 2, 3. Definitely page faults will be there for 1, 2, 3. 1, 2 and 3. 3 page faults. Then 4. 4 will replace 1. 4, 2, 3. Then 5. 5 will replace 2. Then 1 again. 1 will replace 3. Then 2. 2 will have definitely a page fault. It will replace 4. Then again 3. 3 will replace 5. 4. Oh, so option B, all are having page fault. All are having page fault means option B, 10 page faults are there. 10 page fault आ रहे हैं. 10 page faults for 3 frames. Let's go with option B, 4 frames. I can go like this way, 4 frames. 1, 2, 3 and 4 definitely will be there. 4 page faults. For 5, we will replace 1. Then for 2, 1, 2 will be replaced. For 2, 3 will be replaced. For 4, 3, 4 will be replaced. For 4, 5 will be replaced. For 5, 1 will be replaced. For 4 frames also, you will have 10 page faults. Option B is also wrong. No, there is no any Belady's anomaly for option B also. Belady's anomaly will always say page fault increases. If page fault count are same, it is not Belady's anomaly. Page fault count is same, then Belady's anomaly is not there. Now, somebody has suggested I also should say the same thing to you guys. Once you see 3 frames, 10 fault, all page fault are there. You can't have more than that. So you don't have to even check for 4 frames in this type. Option B, you don't have to, you need not to check option B 4 frames ke saath. Why? Just because anyway 10 faults are there, all pages are having fault. More than that, not possible at all, of course. Okay, let's go with option C. Let me write it down here. 1, 2, 3, 4, 1, 2, 5. 1, 2, 3, 4, 1, 2, 5. 4, 1, 2. Okay, 3 frames. 1, 2 and 3 definitely page fault is there. For 4 you replace 1. For 1 you replace 2. For 2 you replace 3. For 5 you replace 4. For 4 you replace 1. For 1 you replace 2. And for 2 replace 5 again. For this option also, I am getting option C is also I am getting all page faults. I am not getting any hit at all. I am not getting any hit. For option C, yes. For option C also, I am not getting any hit. All 10 false. If all 10 false, then definitely this is also not correct option. No, not correct option. Option D. Let's see option D gives Belady's anomaly or not. 1 2 3 4 1 2 5 1 2 3. Same to same. You will also have option D is also having same. For 3 frames you will have all 10 frames, sorry, 10 faults. Even if you check option D is also having wrong answer. So there is no any option which is correct. मैंने randomly नहीं डाला, मैंने check किया. I wanted to have testing of the students who are coming over here intentionally. Now you can see, you compare yourself with so many students. Now, sir, this fellow is giving answer in 3 seconds. This fellow is giving answer in 2 minutes. Look at the people over here. Look and check their answers. Check their answers. See? A, B, D, A, B, A, B, C, A, B, A, B, A, C, A, D, A only alone, A, B, B, C, A, A, C, D, A, only A. Look at this. There are people who are giving answers and confidently giving the answers here. And same, they will give answer in the final exam also. I just wanted to tell you guys, do not compare yourself with somebody else. These people are just flexing. So many students here only for show off and flexing. Do you understand? Every time it will happen that lakhs of students are writing the GATE exam, but only few are really serious about learning, about preparation, and about their own career. You don't have to compare yourself with somebody else. Compare yourself with your own version of last week and last month, if I am improving or not. That's it. Two faults in frame 3 and 4 for D. Two faults or two hit. For frame number 3, 1, 2, 3, 1, 4 will replace 1, 1 will replace 2, 2 will replace 3, 5 will replace this. Okay. Two hits are there for option D. 1 and 2. Okay. Fine. And 3. Okay. Two hits are there for 4 frames. 1, 2, 3, 4. Then 1, 2. Hit and hit. Then 5 will replace 1, 2. Anyway, if you have 3 frames, 10 faults, okay, not there. 8 faults are there. But still you will not have any Belady's anomaly. 8 faults for both in option D, it's fine, but still Belady's anomaly is not there. Belady's anomaly is not there. Okay? Chalo. Next question. Here it is. Another page replacement algorithm question. Now, try to solve this. Do complete OS in English. This year, beta, it's not possible. Yes, strictly greater. Then only Belady is anomaly. मैक्स नंबर वाले टॉपिक CPU शेड्यूलिंग, वर्चुअल मेमोरी, पेज रिप्लेसमेंट्स, मेमोरी मैनेजमेंट। You need to apply optimal policy. Total page fault 4. If you have 4 page frames, number of page fault are 4. Let's see 4 page frames. 2, 5, 1 and 5. No, 5. Again 6. 2, 5, 1, 6. 2, 5, 1 and 6 page fault. After that, you have all repeated options. All these are repeated. 5, 2, 1, 6. All these are repeated only. There is no any unique page. So only 4 unique pages are there. If you have minimum 4 frames, then definitely you will have 4 page faults to keep these 4 pages and done. So 4 frames, number of page fault 4, option A is correct. 5 frames, even if you will increase frames, you have 4 unique pages only. Maximum 4 page faults will be there. Option B wrong. Anyway gone. You don't have to solve it. You don't have to solve it once you observe. And that is where the toppers are getting ahead of the average students. Average students are doing everything. Topper students are putting some kind of smartness and intelligence based on the question. And that cannot be learnt in the classroom. I cannot give you all the tricks which can be asked in the gate examination like this. You will have to put up your mind over there. So gone. Option C. Having 6 frames, still page fault 4. Yes, true, definitely. 3 page frames, number of page fault are 4. That I need to check if it is possible or not possible. Maybe I don't know. So 2, 5, 1. 3 frames, 3 pages, 2 page fault, no. 5, no page fault. 6. For 6, I'll check out the future. Future 5 and 2 are in the nearby. 1 will be little far away. So I'll have to replace 1 by 6. 4 page fault till now. Now, definitely 5 and 2 will be page fault and 1 will not be a page fault. Okay, 1 will be, sorry, 2 and 5 will be available. So no page fault. 1 is page fault. What page I'll have to replace? Again, 2 and 5 I'll have to keep. 6 I'll have to replace by 1. So 2, 1, 5, no page fault. But for 6, again page fault. Page fault will be definitely more than 4. So option D is also wrong. Next question. I'm writing options here only. 0034, 𝐂123, 𝐂124, and 𝐂164. These are the options I have written over here only. Only option D. C, D. C, D, option D. C, D, option D. In this question, how to understand what they are asking? Last line, can you please read? Arrival time of each process can be. Question तो पढ़ो भाई. मम्मी की याद आ रही है. My mom used to say if I can't write something or I cannot see something, my mom always used to say, do you have eyes or buttons? आंख है या बटन? यहीं तो रखा है, देखो तो सही. पीछे तो देखो, नीचे क्या है ये? So what exactly the question is? The question says that processes their burst times and exactly this. Gantt chart itself is given. At 0 time you are running P1. So definitely P1 should arrive at 0. Options all are having same. P1 runs 1 time unit, remaining is 3, and at 1 P2 comes. Then only P1 will be preempted, P2 comes. If P2 also come at 0 time, definitely you will not run P1 initially. P2 is smaller. SRTF algorithm we have used here. So P2 will arrive definitely at 1. So option A gone. Option A gone from here. Now P2 comes at 1 for sure. After that, look at that, P2 runs for 2 time duration completely, which means P4 doesn't come before that, or maybe it can come till 2. Why? Why? If P2 you run for 1 time duration, P4 can come at 2. Still equal duration, P2 should continue just because it arrives first. So P4 should arrive after 2. P4 should arrival time of P4 should be greater than equal to 2. Okay, fine. Now look at this. After completion of P2, which is completed, you are running P1. Sir, why you are not running P4? P4 is smaller, but still you are running P1. P1 is smaller than P4? No, but you are running P1, which means P1 is only there till now in the system, but P4 did not arrive. P4 did not arrive. If P4 did not arrive, which means arrival time of P4 should be greater than 3, not even equal to 3, greater than 3. Why? Just because at 3, if P4 arrives, P4 should be scheduled. Now look at this. P1 is run for 3 to 4 time unit, remaining is 2, and now P4 is coming. So P4 ka arrival time definitely is exactly 4. Exactly 4. Exactly 4 means either this option or this option. C and D. Okay, now after that P4 runs for 1 time duration, then again P1 runs. What about this P3? Sir, P3 can arrive anytime, I don't care. P3 can arrive at 0 also. P3 can arrive at 1 also, 2 also, 3 also, 4 also. Why? Just because, sir, P3 is biggest process among all. Even if it comes at 0 or if it comes at 1 or it comes at 2 or 3 or 4 or whatever, then I don't care, just because I will run P3 at the end. But arrival time of P3 should be lesser than or equal to 7. Why? Just because till 7 all of my P1, P2, P4 will be completed. So arrival time of P3 should be greater than equal to 0 and less than equal to 7. Which option? Option C and D both are correct. C and D both are correct. C and D both are correct, just because P3 is the biggest process. You can make it arrive anytime, even at 0, 1, 2, 3, 4, 5, 6, 7. 7 के बाद नहीं आना चाहिए. It should not come after 7. Why? If it comes after 7, then you will have idle period here. Chalo, next question. Easy. What I should explain again? SRTF you don't know? What should I explain again? In previous one, what should I explain? Complete question. Beta, you need to practice a little bit more of SRTF algorithm. What it says, question. Process is brought to ready state always by the job scheduler. No, wrong. Incorrect. Incorrect पूछा है. So option A we will tick mark. Why? In the ready state, definitely processes are coming from the new state, but apart from that, some preemption also happens. So from running state also process can come into ready state. After completion of the blocked process IO, process can enter into ready state. So process can enter into ready state from 3 possible ways. Process is brought to ready state always. No, not always. Not always. Can be brought? Yes, true. Sometimes yes, but always nah. Option A is incorrect. A process can kill itself and other processes too. Yes. Process can terminate itself. That is what the normal rule we have. Running process can make it terminated. Yes, true. But other processes, yes. Sometimes you don't know about the rule, but I'll tell you. There are some, relations between the processes, parent process, child process. We create through the fork call. Na? So what happens if parent process wants to terminate, then it will kill all its child processes, and then what happens? It will kill itself. Yes, that's the rule. I have implemented it in IISc Bangalore. We had in first semester operating system course, and in that we had to work on an operating system which is open source OS by Stanford, I guess. Name is Pint OS, Pint OS. It is available online. You can search it now also. So in that, one of the module was this only, that when the parent process will terminate, it will kill all of its children. It happens, yes. So it is true. If it is true, then option B is not correct for us. We want to make incorrect tick marked. If all processes arrive at 0, then SRTF algorithm will provide lesser average waiting time than SJF algorithm for their execution on single CPU. Incorrect. Why? If all processes are arriving at 0, then SRTF, SJF will work same to same. There is no any preemption in happening in the SRTF algorithm. It is the classroom training explanation. We have discussed it many a times. SJF, SRTF, same Gantt chart. In SRTF, preemption happens only when later arriving process, which is coming late, is having smaller burst time. Then, so here, no preemption needed. SJF, SRTF, same to same behavior, same average waiting time. Lesser, no, incorrect. When a process needs any resource, then the process requests operating system to allocate the resources to process. True. Yes, that happens. Why? Just because without operating system's permission, process cannot take the resource by itself. So this statement is true. So option A and C are incorrect. B and D are correct. How to guess these exceptions? Where is exception? Where is exception? There is no any exception here. Where is exception? Initially always by long-term scheduler. There is no any word initially. There is no any word admitted. You should catch the phrase and words. No, it's not exception, beta. It's not exception. Can kill? Yes, can. A process cannot kill all other processes. Nah. In the computer system, one process cannot kill all the processes. Always possible? No. Can? Sometimes possible? Yes, sometimes possible. That's why can. A process can kill its child processes. True. That's why can. Can means yes, sometimes possible, not always. True. Understanding always versus can be possible. Sir, if preemptive, non-preemptive not mentioned, what do you assume? In which question? There is only algorithm which is priority based algorithm where this should be mentioned. Apart from that, every algorithm is having specific name and specific type. Next question, very simple it is. Very simple it is, very, very simple. But again, you need deep thinking about the questions. Deep thinking. Consider a process scenario in which there are n number of processes, n greater than 1 means at least 2 processes are there. All processes arrive at time 0 and having distinct CPU burst times. All processes already arrived at 0. Consider all processes do not have any IO requirements. Which of the process execution policy will not cause any process preemption ever for execution of this process scenario on single CPU? See, just now we have seen if all processes have already arrived, that means SRTF will not have any preemption. Priority based algorithm also will not have any preemption. Why? Just because in priority based algorithm also, when preemptive version we use, later arriving process has higher priority, then preemption happens. If there is no any later arriving process, just because all are arriving together, it's all non-preemptive execution. Non-preemptive shortest job first, yes, no preemption ever. Preemptive shortest remaining time first, yes, no preemption ever. Just now only I explained. Preemptive longest remaining time first, preemption will happen over here. Question says distinct CPU burst time. We have seen in the longest remaining time first, preemption will happen. Round robin will not cause any preemption ever. I don't know. In round robin, I cannot confirm until I have quantum and burst time of all the processes given to me directly. There is no any relationship between this given. So I don't know. Preemption may happen, preemption may not happen. I don't know. So preemption, process preemption will not happen. I don't know. It may happen. So option only A and B are correct. Only A and B. C, definitely there will be. Definitely there will be preemption in the longest remaining time first. Only A and B will not have preemption. C will have preemption. चलिए, system is unsafe, or maybe system is safe and safe sequences are given 1 2 3 4 5. I am writing option B. Safe sequence is 1 2 3 4 5, which means P1 P2 P3 P4 P5. Option C says 1 3 2 4 5, 1 3 2 4 and 5. And option D says 1 4 3 2 5, 1 4 3 2 and 5. चेक करो. C preemption due to, beta option C में preemption happens because when you run the highest runtime process or highest burst time process, what happens? The highest burst time process will sometimes become, anytime at certain point of time, it will become the lower burst time process just because it will run. So its remaining time will reduce, and it will reduce that much that that process will no longer be the highest or longest burst time process. So other process will run. Akash, practice more, whatever questions you can, and write the test of completed topics. You need to calculate the need over here, and after that you can easily solve the question. In question, it is mentioned total number of resources, not available resources. Yes. So available resources you need to calculate by subtracting total minus allocation. Look at this. Allocated A allocated 1 to P1, P2 and 1 to P3. Total 2 allocated. If 2 allocated among total 3, then how many available? Available will be for A, 1 is available. For B, 14. Among 14, 6 and 3, 9 are gone, remaining 5. For C, allocated 5, 3, 8 and 9, remaining 2 among 11. For D, 2, 4, 6, 7, 8, 12. All gone. D, nothing is available. 1, 5, 2, 0 are available initially. Now, let's calculate need. A, B, C, D. How do you calculate? 0, 0, 0, 0, 2. 0, 2, 2. Here, 1, 0, 0, 0. 1, 0, 0, 0. Then 1, 3, 5, 4. 1, 3, 5 and 4. 0, 6, 3, 2. 0, 6, 3 and 2. Here we have P5, 0, 0, 0, 1, 4. 0, 0, 1 and 4. These are the needs. Now what? With available 1520, 1520, 1520, I can continue P1 just because P1 is in all the option B, C and D. If I continue with P1, after P1, it's allocated 0, 0, 0, 2 will be added. 0, 0, 0 and 2. 1522. 1522. After that, 1522 option B. No. See, process P2 I cannot run with 1522. I do not have 7 of B. P4 also I cannot. Sorry, P5 I cannot. P2 also I cannot. So P2 I cannot. After P1, option B gone. Option B gone. 2 cannot be next. P2 cannot be next. P3 can be next. Yes. P4 can be next. Let's run P3. If you run P3 or P4, you will have so many resources added. So many. Look at this. Tree of B and C and D. So after 3, 2, 4, 5, everything can be done, I guess. So option C and D should be correct. C and D should be correct. Yes. C and D both should be correct. C and D should be correct. If you go with option C, which says after P1, let's go with P3, 1, 3, 5, 4. 1, 3, 5 and 4. 2, 8, 7, 6. 2, 8, 7, 6. You will complete all the remaining process ka need easily. And similarly here also 6, 3 and 2. Definitely after 1 and 3 or 1 and 4, you can complete all the processes. So system is safe. Safe states are either C or D option. Next question. Easy, very easy. Simple, direct question from the classroom. Too easy it is. In multi-threading concept, open file signals register said that code section can be shared among multiple threads. Option A is wrong. Not correct पूछा है. So this is not correct. Why? We can share the code section etc, but register sets are not shared among the threads. Option A is not correct. In fork system call, fork function always returns a positive value to the caller process. True? No. Wrong. Why wrong? Just because if the process creation got failed, then caller process will get a negative value also. So option B is also not correct. In SRTF, preemptive scheduling algorithm behave like non-preemptive when burst time of incoming processes are in increasing order, which means if new process comes and its burst time is greater than the previous process, of course it will not preempt the previous process for sure. Preemption happens when new process which is coming later, that process has smaller burst time. But this says increasing order means greater burst time. Not possible. So this is true statement. So here no preemption happens. Multi-level feedback queue scheduling algorithm may suffer from starvation. True. Yes. Option A and B are only correct. Next question. Again, very simple. Very simple question. Hmm. Is not correct. Again, false. Two processes are in starvation, then they are called as deadlocked to. No. False. Why false? Not correct. False only. We will have to tick mark. Why? Just because starvation is different, deadlock is different. Starved processes will be starved, may get CPU later on, but not deadlocked. We cannot confirm it. If two processes are waiting for an instance of resources which are held by each other, then it is confirmed that they both are deadlocked. Option B is correct or not? If two processes are waiting for an instance of resources which are held by each other, P1 is waiting for one instance which is held by P2, and P2 is waiting for an instance which is held by P1. Is there a possibility of deadlock here? Is there a possibility of deadlock here? Possibility, yes. But it is confirmed that they both are deadlocked? No. False. Why? It may possible that another instance is available for this resource, which is free. So P2 can get that instance and can execute. It is possible that this resource may have other instance. not given that processes are having only single instance. So confirmed nahi hai. Deadlock, no, not confirmed. If two processes are waiting for same resource, then it is confirmed that they both are deadlocked. If two processes are waiting for same resource, then it is confirmed that both are deadlocked. No. Why? If let's say P1 and P2 waiting for a resource R1, that R1 is with some other process P3. Where is the deadlock? No, there is no any deadlock. But P1 and P2 both are waiting. Yes, confirmed deadlock. No, confirmed deadlock is not there. C option is also incorrect. Two processes are not waiting for any resource, then it is confirmed that they both are not deadlocked. Yes, this is true. Not deadlocked, yes, we can say if they are not waiting for any resource. If two processes are not waiting for any resource, not waiting means they are normal. Normal means till now they are not deadlocked for sure. It is confirmed they are not deadlocked as of now. So option D is true. Why B is incorrect? Why not? Multiple instances of a process or resource can be possible, na? In question, it is not given. One instance of different processes from for each other. One instance processes are waiting and those instances are held by each other, which means process P1 is waiting for R1 ka one instance, P2 is waiting for R2's one instance. Like this. What is the answer of this question? This question is about race condition. Race condition. Okay, let's try to run the processes one by one. Initially, x is 14. X is 14. Let's run P1 first. Y becomes 14. You do single end is, what does it mean? Single end means bitwise end between Y and 7. Y is 14, which is 1110, and 7 is 110. So if you will do, of course, so many zeros are ahead. If you'll do bitwise end, you will have only value 7. So X becomes 7 further finally. Here Z is initialized with 7. A is equal to Z, which means 7. Here we are putting some value in t, but finally we are putting value of a into x. So you can just imagine, my dear friends and students, this particular statement is nothing but only plus plus a. Just because I want to just increase value of a, which will be put into x. I don't want to keep t in x. So we are not putting t into x. A 7 plus a 7 plus 1 8, which we put in x, x becomes 8. Finally, value of x is 8, which is not there present over here. Fine, no option is correct. Again, from starting, let's run completely process P2 then P1. If you put value P2 and P1, what happens? Let's see. P2 runs, x value is 14, z value is 14. 14 comes into a, 14 comes into a, plus a 15, and 15 comes into x. X becomes 15. Now x is equal to y is equal to x, 15, y which is 15 and 7. P2 it will be short circuited. It doesn't matter. Okay. Yes, this z minus 6, z was what? 7, na? True condition. Aha. That I have missed. P1 will be 6 only. Yes, true. P1 will be 6 only. But anyway, there is no any short circuit. अच्छा, शुरुआत से करते हैं. Let me just take once again. 14 is this only, right? And then 7, this. If you have and it becomes 6. Okay, fine. My bad. Seriously. A is equal to Z, which is ultimately value of A, 6. 6 minus 6 is 0. Condition is false. When condition is false, you need to do plus A for sure. Plus A is 7. X becomes 7. Option D looks correct. Yes. I have made mistake quickly. Fine, I have corrected it. Now next, A option 7. One option is fine. Now let's run P2 first. X is 14, Z is 14, A is equal to 14, T is equal to something Z minus 6. 14 minus 6 is 8. Condition is true. I'll have to go with another option. A becomes 15. So A becomes 15, which is X becomes 15. X is 15. Let's go with this now. 15 and 7. So we get 7. X value 7. X value 7. Anyway, it is there. Same to same. Same to same. First option, this was correct, na? Second time when I am running P2 and then P1. Yes. But 7 is still answer. Fine, 7 is still an answer. If I run P1 completely then P2, or P2 completely then P1, then there is same answer 7 I am getting. If I am running P1 then P2, For P2, 6 will be 6 only. It is condition false. I am not running. Okay, anyway, let me make it possible like this. Completely P1, then P2, value of X, I am getting 6, not 7. You are saying this? Fine. No option. Fine. Then I am running P2. Then after that P1, I am getting value 7, which is option D. 6 anyway is not there. 6 anyway is not there. So leave it. Now let's make these two processes using the value of X directly, same 14 and 14. If this value read 14 here, this value read 14 over here, what happens? 14 and 7. This is 14 and 7 is 6. 14, A is equal to 14. 14 condition is true. I'll have to go with this 15. So if both are reading X value here and here, concurrently 14 and 14, this will make Y is equal to 6. This will make A is equal to 15. If I put this later, option 15 will be true. Possible answer is A. 15 is also possible. 15 is also possible if both will read value of X concurrently. This will make 6. This will make 15. 6 is not available here. So 15 is possible. Final value of X, 15 and 7. Among them, 1 can be a possible option. And 6 also. Chalo. Next question. Study skills after long. I am good. How are you? Question is this. Fails to guarantee mutual exclusion. Flag and flag 2 are Boolean variables shared. Both are shared. Both are initialized to true initially, which is false. False is asked. Flag initialized to true. Both flags are initialized to true. And false is asked. Which option is false? solution fails to guarantee mutual exclusion, true. Why? If both processes are arriving, look at this, doesn't matter if flag is initialized to true or false, as soon as they enter they are making for flag of each other of its own to false. P1 making its own flag to false, P2 making its own flag to false. Now see, there is no any semicolon here. No, you can check over here, no semicolon. This critical section and flag is equal to true is inside the critical section itself, or inside this loop. So flag 2 is false, yes, flag 2 false. One by one, if processes are running and making their own flag 2 false, what happens? Flag 2 false, condition true, process P1 can enter into critical section. Preemption happens, P2 flag 1 is false, yes, P2 also can enter into critical section. So it is not false. Guarantee to mutual exclusion fails to guarantee. Fails to guarantee mutual exclusion. It is true statement. So option A is not correct. Mutual exclusion is not guaranteed. Statement is true. B. Solution fails to prevent deadlock. There is deadlock. Possible deadlock. Possibly deadlock. No, there is no any deadlock. Both the processes can go further. There is no any deadlock. So fails to prevent deadlock. Condition statement is false. It is able to prevent the deadlock. There is no any deadlock here. Is there any deadlock? Is there any deadlock? No. So it is preventing deadlock. Option B is false. Option C, in given solution P1 and P2 never stops for critical section. This statement is again false. Why? Why? Look at this. If only P1 arrives. If P1 arrives, then look at this. Flag 1 is true. Flag 2 is true. Flag 1 false. Flag 2 is equal to false. Condition false. Why? Just because flag is true right now. If condition is false, P1 is not able to enter into critical section. P1 is not able to enter into critical section until P2 comes and making its own flag to false. Then only P1 can enter. So if alone P1 comes or alone P2 comes, then progress may not happen over here. But here, given solution never stops false. Starvation is there. Given solution prevents deadlock and also guarantees mutual exclusion. False. Guarantee mutual exclusion. Option A, we have already made it, right? So it does not guarantee mutual exclusion. False. If it satisfies mutual exclusion, then deadlock never occur. ऐसा कुछ नहीं है. Study skills, never ever. Don't think like that way, ever. You remember hardware solution? CPU hardware solution? Bit of starvation? Doesn't matter bit of starvation. Starvation is a starvation. Test and set satisfy mutual exclusion. Bounded waiting? No. Bounded waiting is not there in test and set and swap both. Test and set and swap both satisfy mutual exclusion. True. Correct only, I'll have to tick mark. Test and set satisfy progress but swap not? No. Both satisfy mutual exclusion and swap. Both mutual exclusion and progress both are satisfied in both. Test and set swap both may not satisfy bounded waiting. True. Option B and D are correct here. Yes, many of you are having correct answers. Ooh. Good question. you will have to calculate average waiting time for three algorithms. So questions are this. Options: RR algorithm have an intermediate value for average waiting time between SJF and FCFS and some other options. So you need to calculate average waiting time for all three algorithms: FCFS, non-preemptive SJF, and round robin. And then you can tick mark the options. In FCFS, if processes are arriving at same time, then run them based on their ID. In बयालीस 47 आएगा 11.4775 For FCFS, average waiting time we are getting 11.75, SJF 4.25, RR 8. Now, how quickly you can calculate is the scene over here. Practice more and more, you can solve the questions quickly. So, of course, RR is, SJF is giving minimum, next RR, and then FCF is giving too much. RR algorithm has an intermediate value for average waiting time, true statement. True is asked? Yes, true. True is asked. Next, SJF policy results in less than half of the average waiting time obtained with FCFS. FCFS 11.75 इसका half होगा 5.5 के ऊपर, that is more than 5.5, of course lesser than half. True. Irrespective of given scenario, SJF always will result in maximum average waiting time. Maximum nahi, minimum, it gives minimum. The round robin has given lower average waiting time than FCFS. True. Option A, B, D are correct. Observation, just get the values, then rest of the things are very easy to calculate. Oh. Which of the following resource allocation graph represents a deadlock situation? Single instances. Yes, practice based question for sure, but we need to make it quick. That's what the the thing, as quick as possible. If you can get the answer, that is what help you, that is what gonna help you in examination. Make the wait for graph and it will be easy for you. P1 is waiting for R1, which is with P2. P2 is waiting for R2 and R3 also. R2 is with P1. Anyway, cycle is there, gone. So option A has deadlock for sure. Option B, P1, P2, P3, P4. P1 is waiting for R1. R1 is not there with somebody. Fine. P1 is waiting with for R2. R2 is with P3. So P1 is waiting for P3. P2 and P4 are also waiting for R2. Means both all are waiting for P3. P3 is waiting for R4. R4 is with P4. R4 is with P4. P3 is waiting for P4. Gone. Gone, gone, gone. Option C is also having deadlock. Option B, P1, P2, P3, P4. P1 is waiting for R1. R1 is not with anyone. P1 is waiting for R2. Same to same graph. Looks like same to same. P1 is waiting with R2. R2 is with P3. P1 is waiting for P3. Same P2 and P4 are also waiting for P3. P3 is waiting for R4, which is not with somebody else. R3, P2 is waiting for R3 also. R3 is with P4. So P2 is waiting for P4. Cool enough. Then P4 is waiting for R2 and R4. R2 is it with P3, but R4 is not with someone. Option B is not having deadlock. No deadlock. Option D. There is no any cycle in option B. 1, 2, 2, P2 waiting for R2. R2 is with P4. Okay. Now P1 is waiting for R2. R2 is with P4. P3 is waiting for R2. R2 is with P4. P4 is waiting for R4. R4 is with P3. P4 and P3. There is a cycle. Option D is also having deadlock. So option A, C, D are having deadlock. Yes. Good enough. Nice. Next question. Deadlock. Cycle is there. P2 to P4. Which one? Where? P2 is waiting for R3. R3 is with P4. Yes. But P4 is not waiting for any resource which is with P2. Na? P2 is not holding any resource at all in option B. Option B में cycle कहाँ है? Option B में cycle कहाँ है? Where is the cycle? There is no any incoming on P4 for cycle. There is no any incoming for a cycle on P2. Now, B option not having any deadlock. Deadlock prevention. To prevent circular wait, a process cannot request for a resource RJ while holding resource. There should be some correction over here. While holding resource RI होना चाहिए. The statement should be correct. To prevent circular wait, a process cannot request for a resource Rj while holding a resource Ri where I is less than J. I don't know what kind of circular wait execution is implemented. See, to prevent circular wait, either the request should be done in increasing order or decreasing order. That should be mentioned over here. There is no any default case I can take. So this can be true, this can be false, depending on what kind of implementation is given. So for A option, I cannot say it is correct only. I don't know. Cannot be, I don't know. I don't know. Why? Just because it is true also, it is false also, depending on what order you want to implement, increasing or decreasing. So option A gone, not correct. To prevent deadlock, a process should request and hold resources only when all resources are available. Yes, this is hold or wait option. B is correct. To prevent deadlock, each process should satisfy all conditions like mutual exclusion, hold and wait. No, preemption and circular wait, false. To prevent deadlock, one of these conditions should fail. If all conditions are satisfied, then there will be a deadlock. If all processes are independent with its own resources, then definitely deadlock will be prevented. Option D is true. Option A, to make it true, we need more information that what exactly the policy is applied. While holding the lower number of resource number, a process can request for larger resource number. That's it. If it is given in the question, then I can say option A is true or not. It should be given that in what order I will ask or I will implement the resource request for the processes to prevent the deadlock. It should be given in the question, increasing or decreasing. Based on that, I can make a decision. Okay, next question. It is ambiguity, then yes, it is half statement. Statement is not completely given. That's why we are not saying it is correct. Hmm. Consider a disk device queue in which more than one requests are in pending. Which of the following statement is or are disadvantages of shortest seek time first algorithm? It takes high overhead to calculate seek time in advance. It is the disadvantage, yes. In SSTF, we need to calculate first that how much time is taken or will be taken to visit each and every remaining request. Based on that, whichever is the nearest request, that we will fulfill first. So it will take time, of course. Second option, it can cause a starvation for a request if it has higher seek time as compared to incoming request. So if so many requests are coming, keep coming, which are closer one, and one request which is pending is very far, then the far request can have starvation. True. This is also one of the disadvantage. High variance of response time of various requests, that is also disadvantage. Variance means, see, nearest request will be responded quickly and solved quickly, serviced quickly. Their response time is less. Request comes, quickly serviced. Response time is less. Disk will take lesser time to respond about the request. But the farther requests will take a lot of time to request. Why? Just because for the service, those will be taken at the end. That's why. Increase in average response time. Average response time is actually decreased. Where? In the SSTF. So option D is not the disadvantage. It is false statement. Option A, B, and C are only correct. Very easy question. Which of the following statement is or are not incorrect? Not incorrect means correct, true statement. In pure demand paging, a process starts with one page in memory. No, 0 pages in memory. False. Pure demand paging, no page is available in main memory initially. In demand paging, a single instruction can cause multiple page fault. True. So many students will not know about it. See, while execution of instruction, CPU can access memory two times. One for instruction fetch, another for operand fetch. So for instruction fetch, let's say CPU started execution instruction, and instruction fetch, for instruction fetch, CPU goes to the memory, fault. Instruction is not available in main memory, CPU brings it after the fault. Instruction is available, fetch happens. After fetch, CPU wants some data. Data can be in another page, yes. And for data or operand fetch, again page fault occurs, possible, yes. So option B is correct. Hardware support is needed to implement demand paging. True. Why? Just because as soon as there is a page fault, it is a software interrupt which goes to the CPU, and CPU will have to stop the current instruction. So option C is wrong. Means correct it is that it needs hardware support for demand paging, just because for page fault implementation we need interrupt service. A valid page means page is legal and it is in main memory. True. Option C is true. B, C, D are correct. The meaning of valid page is the page is in main memory. Again, from virtual memory only question is there. Yes, Swaroop, definitely. MMU itself is a hardware. For entire virtual memory environment, we need MMU support for sure. So MMU is a hardware, we need it. Disk scheduling algorithm also works for SSDs. Guru, first you tell me how the SSDs are accessed. Page fault is a trap to OS while CPU executes an instruction. True. Selection of a specific page replacement policy in operating system may lead to have an increased page fault, page table entry size in paged memory system. True. Why? See what happens if you are selecting a specific page replacement policy, which is like LRU. For LRU, what happens, whichever page referenced when, its information can be mentioned in the page table, reference bits, etc., etc. So a page table entry size may increase based on the page replacement policy selection. All TLB entry should be made invalid while context switch when TLB entry contains only translation. True. Why? TLB contains page number and their frame numbers, the translation, right? Page table entries. But even the page table entry we have only page table entry means these all entries are belonging to the current running process. If process is switched, other process comes, all these TLB entries are no more valid. Why? For other process, its own page table is there, and its own page table entries which are different than the current process which we replaced from the CPU. So the TLB entries should be replaced. This can be false when we keep in the TLB along with the entry we keep the page number, sorry, process number, process ID. If we keep the TLB like this, the process P1 ka TLB entry page number 6 is available on frame number 9. Like this, if we keep the entry in the TLB, then in that case, if we keep process ID along with translation, then we can keep the TLB entry of other processes together in the TLB. So making all entries invalid will not be needed at that case. Swapping of pages is required for every page fault. False. No. Sometimes if frame is empty, page swapping is not needed. Page sharing. Another question. Playlist where I can learn introduction to CS, IT and fundamental of computer system in English? No, beta. There is no any such thing available. TLB with multi-level paging is needed, of course. But in TLB, we directly keep the direct entry. We don't need multi-level page information. Directly, frame number we can keep. We don't have to keep multiple level का TLB and all. प्रोबेबिलिटी का महा रिविजन और महाअभ्यास नहीं हुआ. मैथमेटिक्स लास्ट वीकेंड जो सर ने लिया था उसमें नहीं हुआ. मैं बोल दूंगा सर को. चलिए. नॉट ट्रू, फॉल्स पूछा है. फॉल्स. Implementation of page sharing is easy with standard single level paging, but and with inverted paging also no. In inverted paging, it is difficult to implement page sharing. Page sharing, how we'll do? Normal paging, page table of P1 process and page table of P2 process. If let's say one page is shared which is available currently on page number frame number 15, this page, so here also you can keep frame number 15 and here also you can keep frame number 15. Sharing is done. Simple. But in inverted page, one particular frame is holding a page which is shared between two processes. In front of inverted page table ka single entry, you cannot keep two page numbers of two different processes. Inverted paging, not possible. Difficult. Why? In inverted page table, what you keep is in front of frame number 15, you keep process ID and page number. Only one process ID and page number you can keep. So this frame number 15 is holding a page either for P1 or P2, not for both, not possible sharing. Implementation of page sharing is easy with standard, but not with inverted. True. Page sharing is easy with inverted, not. Oh, option it is not true. Not true means option A, C, and D. Option B is only correct. Oh, simple question it is again. From disk only. Disk and virtual memory environment. One doubt can I ask? You can ask. That depends on me if I want to answer it or not, but you can to ask, na? Definitely. Anji, which of the following statement is or are correct regarding paged memory environment techniques? Disk IO is more efficient when page size is larger. When page size is larger, disk IO means accessing to the disk will be efficient. No. Okay, I'm just waiting 1 more minute for your answers. No, beta. In gate exam, that will not happen. Don't worry. Disk IO is more efficient when page size is larger. False. Why? See, when page size is big, while page fault, what happens? You need to bring bigger page, larger data or more data if you read from disk or write into the disk while swapping the page. Of course, it will take more time. Efficiency will be reduced. Disk is slower. That's why false. Forward mapped page table in multi-level paging, address translation works from outer to inner table. True. This is something like regular stuff we have. For forward mapped page table is outer will give you inner and inner to actual page numbers you will or frame numbers you will give. Virtual memory concept increase the number of page frames, sometimes may increase the number of page fault also. Yes, true. Belady's anomaly. For a small virtual address space, inverted page table size is smaller than the regular page table size. Wrong. When you have virtual address space big means process size is very big. That's why number of pages will be more than number of frames. And that is why page table size in normal page table will be very big, just because number of pages are so many. So for bigger virtual memory or virtual address space, it will be beneficial to have inverted paging rather than normal paging. So this is false. Option B and C are only correct. Next question. We do have 5 partitions, 5 processes. Question is this. Option C. Option C is Belady's anomaly. Just search and learn it. Options. Maximum degree of multiprogramming. How many processes you can keep? Maximum is maximum degree of multiprogramming. What is the total internal fragmentation size? For best fit, you give the smallest partition to each process. First P1 comes, smallest partition 150 MB, 200 MB partition will be given to it. Then 400 MB, smallest partition is just 500 MB only. P3 270, smallest one is 300 only. P4 180 MB, smallest is 250 only. And 80 MB, for that 100 MB. All 5 processes can store. So multi-programming 5, all 5 processes we can store. And internal fragmentation is how much? For best fit internal fragmentation, let's calculate internal fragmentation. What is internal fragmentation? Extra space. How much extra space we have provided to the processes, which is not needed. Summation of all minus summation of all this. 1000, 250, 350. 1350 minus. This one is 450, and 150 is 600, 700, 1080. 270. 270 is the internal fragmentation. First fit. Let's see first fit how it happens. The very first one we will give 150 ko. First one 250 we will give. 400 ko first from starting here. 400 can be stored in 500 only. P3 270 we cannot keep here. 300 only we will have to give. For 180 not here, for sure 200. And last one 80, of course 200. All 5 processes we can store in first fit. Yes. So same 270 MB will be the internal fragmentation for sure. Last one, worst fit. First process we give the biggest process, partition 500. If 500 is given to first process, then P2 definitely will not be able to store. So best fit and first fit both are having exactly same maximum degree of multiprogramming and maximum internal fragmentation total size. चलिए नेक्स्ट क्वेश्चन, डिस्क का क्वेश्चन इट इज. For inside implementation of malloc, C programming also uses this. No beta. These are for process storage, not for some variable storage in the memory. Sir, for entire year, if you can bring this kind of questions, beta, for entire year we provide lot of DPPs and a lot of weekly test questions and the paid batches. Consider a file which is stored on disk with either contiguous allocation or linked allocation or indexed allocation method, depends whichever you are using. The file is stored already on 100 blocks. Which of the following will take minimum number of disk block access of the file for insertion of a new block? Insertion of a new block at starting if file is stored contiguous, file allocation method. Minimum, can't say. Why? Just because at starting, if we don't have free block available, then in the beginning, if we don't have free blocks, I'll have to shift all the blocks backside and then insert the new block at the first. In the contiguous, you will have to keep all the blocks together on the sequence, right? If before this block, new block is not empty, then I'll have to shift all these. So cannot say option A is true or not. Option B, insertion of a new block after 50th block of the file if file is stored using linked allocation. Of course, this is for sure false. Why? Just because when you insert in the middle of the linked list, you need to traverse 50 block anyway. You'll have to access to reach to the middle. Insertion of a new block in the end if file is stored using index file block allocation method. This can be true. Anywhere you can insert a new block with just 2 block accesses. Just 2 block. How? One is the index block. In index block, you keep the indexes. Yes. If you are inserting a new block, you access that new block ka content, copy it in the disk, and you then access the index and update it by making its number over there. That's it. Only 2 blocks will be accessed and a new block can be inserted. That's it. Insertion of a new block in the end if file is stored using contiguous allocation method. Again, this can be true if we have at the end block available freely. D also true if we have free block available. If not, then no. So here actually question is certainly not complete. Question should mention that how many blocks are empty before the file and after the file. It should be mentioned. If at the end we have empty blocks available, yes, true. If not, then there is a flexibility issue. So the question should actually mention it as incomplete question. It should mention it. Question should mention it that at the end of the file we do have enough empty blocks or not. Before the file we have enough empty blocks or not. Based on that we can just answer whichever is correct. Assumption memory is available, then option A and D both can be correct. In the starting of the block, if we need to insert, file is already here. New block you can insert on the empty position and then change the directory entry. You can do that also without shifting the blocks. Wow, perfect timing. 2 hours, 20 questions. Even more than that, 21 question exactly we have solved today. We are good to go. Now NAT type, MCQ type and some practice questions we will have in the evening time, 7 p.m. onwards in Hindi channel, on Hindi channel. So again, let's meet at that particular time, 7 p.m. and we will have another practice session from 7 p.m. onwards. Okay, let's meet at 7 p.m. again. Go, 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 run, run, run. Don't waste your time. Just enjoy your learning. Thank you so much. Bye-bye.